Hello guys, welcome to Speedlabs, and today I have came with a new topic that is very interesting and is known as Newton's laws of motion. So today we will see what is Newton's laws of motion and what is its significance. Okay, so let us start with Newton's first law. So Newton's first law is a very simple law. It states that every body remains in the state of rest, either in the state of motion, until and unless it is compelled by an external force. So basically this law is also known as law of inertia, because alternatively it is just a definition of inertia only. Okay, as I have just explained you this in my previous video, what is inertia, let me explain you again for you. Okay, so let's say if I have a body of mass m. Okay, consider this body of mass m, and this body, consider initially it is at rest. Okay, this is a rough surface. Okay, so according to Newton's first law of motion, we will say that this body will always be in the state of rest, always, until and unless you just applied an external force to change its position. So this is the natural state of the body. Okay, similarly, if I have taken this another example, consider this ball. Let's say consider this ball, and this ball have a mass m1, and let's say this ball is just moving with velocity something v. So it will always move with this velocity v until and unless we applied some force, some external force to stop it. So this is the natural state of the body. So this is basically the Newton's first law. Okay? Every body in this universe will remain in the state of rest or in motion until and unless you just applied an external force. Okay, basically this is the law of inertia. Okay, this is very simple law. Okay, have you understood? Okay, now let us understand with this something with a good example. Okay, consider this ball and it is initially placed at rest. This ball is initially placed at rest. This ball is at rest. Okay, if this boy has kicked this ball after some time, let's say, this ball will come into motion. Initially, the natural state of the body is at rest. But when you have applied, you have just changed the speed as well as direction of this ball, and further this ball came into motion. Okay, with an application of force. Okay, so this is basically Newton's first law. Okay, so Newton's first law states every body will remain in a state of rest, either in motion, until and unless it is compelled by an external force. That is very simple. Understand? Okay. Now further, next we will see an important thing in Newton's law of motion, that is momentum. Momentum is very necessary. Momentum is also required in your studies. Then only you can score good marks. What is momentum? Momentum is a quantity that is basically depends on mass as well as velocity. If something is moving with some velocity, then I will say that it has momentum. The less the velocity, I will say less the momentum. The more the velocity, the more the momentum. Similarly, I can also compare this momentum with the mass also. If something has larger mass, it has larger momentum. It is very difficult to push a truck, understand, because it has a larger mass, so I will say it has a larger momentum. So basically it is the quantity that depends on mass as well as on velocity. It is not a cross product, it is just I have just shown this. Okay. Okay, so basically what is momentum? Momentum is just a product of mass and velocity. It is not a cross product. Remember, this is not a cross product, it is just a dot product. And here, as you know, V is velocity. Velocity is a vector quantity. So momentum is also a vector quantity. And the direction of this momentum is same as the direction of velocity, because m here is a scalar quantity. Understand? So what is the unit of this momentum? We can say the unit of mass. The unit of mass we can say is kg. And what is the unit of this velocity? We know it is meter per second. So what is the unit of this momentum? That is kg meter per second. Okay, this is the unit of momentum. It is the quantity that basically depends on mass as well as velocity. Okay. Now further, The second law is the very important law, and usually you have to remember this because in whole chapter you will use this law maximum time. Understand? So this law is very simple. Just try to understand what I'm saying. So this law states that the rate of change of momentum, the rate at which momentum change directly depends on the net force. And it is very obvious. The more in the shorter time, the more the force you applied, there is a more change in the momentum. So it is very obvious law. I will just make you understand with a very good example. Consider this ball of mass m. Let's say it is moving with initial velocity u. Initially, it is moving with some velocity u. You can consider. And here at this point, consider at this point. Okay, consider this point. I have applied some force. At this point, I have applied some force, some external force. I don't know what the amount of force I have applied, but consider this, I have applied something that is known as force. I have applied something, and with the application of this external thing, the body has changed its velocity and had become v. So initially here, the momentum I can write P1 is equal to m into v. Understand? And here momentum I can write P2 is equal to m into v. M into v. Here you can write m into u. Sorry. Okay. Here, here that is m into u. Okay. Here the momentum is m into u. Here the momentum is m into u, and here after the application of force the momentum is m into v. So what is the change in momentum per unit time? We can calculate. Yes, we can obviously calculate. Let us do in the next slide, and with the help of this you can come into a conclusion that this will give automatically this thing, F equal to ma. Okay. Now consider the previous example. In this, a ball m is moving with velocity u, and here at this point I have applied some force. At this particular point, I have applied some force F. Okay. So here the body after the application of force starts moving with velocity v. So here I have written momentum P is equal to m into u. Here the momentum P2 is basically m into v. So what is change in momentum per unit time? That is delta P is equal to P2 minus P1. Understand? Okay. So what is P2? That is mv minus mu. Okay. Now the momentum per unit time, the change in momentum per unit time, delta P by delta T will be mv minus mu by delta T. So here if I taken m as a common, we can write v minus u by some delta time. That I have considered the time is very small, that is why I have written delta t. So further I know the first equation of motion, that is v is equal to u plus at, and from here we can write v minus u by t is equal to acceleration. So putting this value v minus u by t here, what we will get? We will get m into a. And this thing, the rate of change of momentum is defined as force with the help of Newton's second law. So what we have get? We have get the rate of change of momentum is equal to ma, and that rate of change of momentum is equivalent to the thing you have applied, and this thing is called net force. So here what we will get? We will get as force is equal to mass into acceleration. This is very simple. Understand? So this is the derivation of F equal to ma. Now for your additional information, I will just show you one thing more. Differential form of this second law. This is basically the same, but we will use differential calculus to understand this. Okay. In the same previous example, let us consider the body is moving with a velocity u, and after the application of force F, the body started moving with velocity v. So what is the momentum? Momentum is P. Now the rate of change of momentum I can write dP by dt. Understand? And that momentum is basically m into v, and rate of change of v will differentiate it by with respect to t. Okay, so basically when we will differentiate this thing, this will automatically give me force by the definition of Newton's second law. So F net is equal to, now here always we will consider m as constant, so m will automatically come out. So here m, and we will get dv by dt. And as you know, what is dv by dt? dv by dt is basically a, acceleration. So what is net force? Net force is equal to m into a, mass into acceleration. Remember, in this formula I have considered mass as a constant. This formula F equal to ma is only valid when you have a constant mass. Okay, this is very important. Okay, I hope you understand this. Okay, now further, so what is the unit of force? So basically force have two units. One is absolute unit, first is absolute unit, one is absolute unit, one is absolute unit, that is Newton, that is Newton. Understand? It has absolute unit, that is Newton. Understand? And it has another unit called gravitation. But remember one thing, we can just derive it also. We can derive. Let's say we know F is equal to m into a. Okay. What is the unit of mass? Mass has unit kg. What is the unit of acceleration? That is meter per second square. This thing is all automatically equal to Newton. Okay, so this is Newton basically. The SI unit of this force is basically Newton. And gravitational unit, as you know, it is kilogram. Understand? Kilogram force. Okay, so remember this, it is denoted by N. It is denoted by N. The unit of force is denoted by N. Why? Because Newton has given all these derivations. So he has kept the unit with his name only. Understand? Okay. So I think you have understood the second law as well very efficiently. Okay. Now let us have a question. The question is saying a constant force acts on a body of mass m. Let us write what is given. We have given a mass, that is m equal to 10 kg. It is given. Now produces in it an acceleration of 2, acceleration 0.2. We have given acceleration 0.2 meter per second square. Understand? Now it is saying that calculate the magnitude of force acting on a body. We know, as previously we have seen, F is equal to m into a. We have to calculate the force. So what is the force? Force is equal to mass. Mass we have given 10, and we have given acceleration, that is 0.2, point like this. So what you get? You get F equal to q Newton. That is very, very easy. That is very, very easy question. Understand? The force will be q Newton. Again the next question. See, force has given 24 Newton. We have given force 24 Newton. We have given force, that is 24 Newton, and we have given a mass 2 kg. We have to calculate the acceleration. In this question, in this particular question, he is asking for acceleration. So we can calculate it very easily by applying F equal to ma. We know F is equal to ma. What is force? Force is 24 Newton. And what is acceleration? Sorry, what is mass? Mass is 2. So acceleration will be 12 meter per second. That is very easy. Very, very easy. Understand? So like this, by using this formula F equal to ma, you can calculate force, acceleration, or whatever the question is asking. Okay. Now the last law we have is a very simple law, and everybody in this world knows this. That is Newton's third law of motion. So basically this law states that every action has equal and opposite reaction. What it actually means, like this, in this you can see a ball is inside here, and this bullet is basically projecting this ball in right hand side direction. You can see the ball is just coming right hand direction. Okay, so this ball will automatically apply a backward force also to the cannon. Understand? Means every action has equal and opposite reaction. Like if I will give a very simple example, let's say here is a ball, and if I have thrown this ball to this wall like this with velocity something v, then here the ball will apply this force on this wall in this direction. At the same time, the wall will also apply some force to this ball, and the ball will start move like this. So what it is saying? It is saying that every action, there is an action, na? Every action has equal and opposite reaction. So ball is moving like this, and the ball has applied some force on this ball. At the same time, the ball has also applied some force to the ball. So there is an equal and opposite reaction. Remember this. And remember one thing also, action and reaction. There are two things that acts on different body, not on the same body. In this particular example, the ball has applied force on this wall, but the reaction pair, the ball has applied force on the ball. So the action reaction pairs acts on two different bodies. Remember this, but their magnitude is equal. Understand? The action reaction pair have equal magnitude. So this is basically Newton's third law of motion. Understand? Okay. So as I have told you, this is basically action, and at the same time a reaction also occurs. So if I consider two bodies A and B colliding, okay, if they are colliding, so A will exert some force to B, that is action, but at the same time B will also act some force to A, that is reaction. So both action and reaction are acts on the different bodies but at the same time. Understand? And they have equal magnitude. Understand? Okay. So there are many examples we can see. The examples are gravitational force between the sun and the planets. You know, the sun is in center and planets used to revolve around it. So there's a gravitational force. Sun exerts force on this planet in this direction, but at the same time the planets also exerts the force on the sun because it is an action reaction pair. Similarly, there is a rocket propulsion. When rocket goes into the space, the gases which emits while propagating exerts force in downward direction. So there is an equal and opposite reaction that generates in upward direction. Hence it gets a velocity and moves in forward direction. This is how rocket propagates. Okay. So this is a very short and informative video about Newton's laws of motion, and I hope you understand